Okay, all that's left is to apply transformations to our parent root functions. Let's first recall a little bit about transformations, just to make sure we're all together. X transformations reverse the arithmetic inside the parent operation. So the key is X transformations reverse the arithmetic inside the parent. Y transformations just are a direct result of the arithmetic outside the parent operation. When we see addition or subtraction, that results in a shift. When we see multiplication or division by -1, that results in a reflection. And when we see multiplication or division by a positive number, that results in a stretch or a shrink, compression. Okay, so we'll see those things work out here as we do some examples of graphing root functions that have transformations. So let's try this. Graph using the parent and transformations. And let's look at the function f of x equals, now let's do a square root function first. Let's say, I don't know, let's do 3 times the square root of 2x minus 4. 3 times the square root of 2x minus 4. Okay, we want to do this with transformations in the parent. So we're not going to plug x values into this function directly. We're going to generate the parent function and use transformations applied to that parent. The parent function is what you get if you strip away all of the arithmetic. Get rid of the 3, the times 3, the times 2, and the minus 4, and all that's left is y equals the square root of x, which is simple to generate an xy table. We have to pick x values 0 or bigger, so we'll start with 0. And then we're going to pick things that we can easily take the square root of, such as 1, 4, 9. We can keep going if we like. The y values here are the square roots of those x values, so 0, 1, 2, and 3. Now we're not going to graph anything yet. We have to do our transformations. So let's look at our x transformations. Remember, they reverse the operations on x. So the operations that we see on x are times 2 and then minus 4. So the transformations will reverse the order of these and the operations. So the first thing we're going to do is add 4, and the second thing we're going to do is divide by 2. The y transformations are outside of the square root parent operation, so the only thing there is times 3. And that's it. So let's start manipulating our parent table with these transformations. So I need to do both these transformations to the x column and this one transformation to the y column. So I'll add 4 to my x column in my first step, and I might as well go ahead and multiply my y values by 3. Adding 4 changes my parent reference point of 0, 0, changes that x value to a 4. I've got 5, 8, and 13 for my new x values. Multiplying my y values by 3, I get 0, 3, 6, and 9. My y values are done because I've already taken care of the one transformation. All that's left now is to divide my x values, these new x values, by 2. And I will get my final xy table. So 2, 2.5, 4, 6.5, etc. And my y values go unchanged. So what we should see here, this is my final xy table. I want to give you the idea. Remember, the parent square root function looks like this. Adding 4 to that's going to move it to the right 4 units. Dividing by 2 in the x direction is going to shrink it towards the y-axis. So now it's going to be over here at 2 and kind of taller because it's going to be compressed left to right. And then the y values are going to multiply by 3, and that's simply going to make it even taller. So we should be looking at something starting at 2, 0, that's our reference point, and then kind of growing much faster than a usual square root function. Let's see what it looks like. Okay, so our reference point is at 2, 0. We've got 2.5, so that's just barely past 2, and up to 3. And then 4, so 3, 4, and up to 6. It's up here. And then, let's see, then 6.5. So let's see, 2, 4, 6.5 is here, and then up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 is up here. And so it's good to understand this is a square root function, 2 zeros are reference, because I'm not going to have an arrow going this way. I'm going to have an arrow where the dot, dot, dots are. So it's just going to kind of start at 2, 0 and then grow to the right like this. And we could see like a quick sketch of it up here using what we know about transformations, but having the XY table allows us to get a really precise graph of this function. Let's try one more. So same instructions, graph using the parent and transformations. And let's look at f of x equals, how about 3 minus the cube root of x plus 2. Okay. So same idea, we need the parent first. If we strip away adding the 3 and multiplying by -1 and adding the 2, all that's left as an operation on x is the cube root operation. So that's our parent function. And here we want to pick x values that are easy to take the cube root of. Like you can pick negatives or positives. So I'm going to pick negatives first, like -8 and -1, and then 0. And then I'll pick positives, 1 and 8. And there's a lot more I could go with in either direction. The y values will be the cube roots of those x values. So the cube root of -8 is -2. The cube root of -1 is -1. We get 0, +1, and +2. Now we just need our transformations. The only operation happening on x is +2. So our transformation is just going to be a -2. Now the y transformations, we've got a couple of those outside of the cube root function. The first operation happening to the cube root is multiplied by a negative, so times by -1. And then we got a +3 that we're adding to it, so that's +3. And we do those in that order. So we'll go to our x column and knock out our transformation there of subtraction by 2. And we'll go to our y column and we'll multiply everything by -1 and get an intermediate xy table. So we get new x values of -10, -3, -2, -1, and 6. By the way, 0, 0 is our reference point that we'll keep track of. Our y values are just going to change signs and become +2, +1, 0, -1, -2. So -2, 0 is our new reference point. But we still have to add 3 to the new y value, so we have to do one more step here. And we get our final xy table. The x values don't change. I'll write those down. And our y values become 3 more than they were, so 5, 4, 3, 2, and 1. And -2, 3 is our reference point. Let's see what this graph looks like. Let's graph our reference point first. -2, 3 is up here. -1, 2 is here. and then 6, 1. So 1, 2, 3, 4, 5, 6, 1 is there. Yeah, so we can see how this is a cube root function. It's been flipped over because of this multiplication by -1 on the y and the y transformations. We should get symmetric points to the left, basically across where this reference point is. It's not symmetric over either the axes or the origin, but over the reference point. -3, 4 is up here. That's good. And -10, 5. So -4, 5, 6, 7, 8, 9, 10, and then at 5. So that would be up here. Yeah, so to the left, it curves back the other way and looks like that. And there we go. The graph has been flipped over the x-axis, shifted up 3, and then shifted left 2. That's a way to think about it. That's our transformed cube root function.